All right, now the last question was about a Nash equilibrium. And so if I put up the definition of a Nash equilibrium again here, this is when the players, the participants, will do what is best for them based on the opponent's strategy. And so this is important. I guess at this point in time, it's important to mention kind of one of the assumptions that we are operating with which is complete information. That's it. That all the participants, all players, know everything in the matrix. Okay, everybody knows what's here. So it's not like the matrix isn't. The information is hidden from any player. Every player knows. So Horatio and Albert both know all of this information. And that's one of the assumptions they'll write into the question, is that they assume that there's complete information. And again, in the real world, maybe that's possible, maybe that's not possible. But for these scenarios, it is the case. And actually, in the real world, you'll see sometimes where economists have created or helped to create systems where they try to make things more transparent so that all the players do know the payoffs and that they can understand how their competitors may or may not behave. So let's take a look at this last one here. So what is the Nash equilibrium? So what are they going to do? So if they know all of this, Albert and Horatio know all this information, well, at the end of the day, they know that Albert will always choose to add a new trick. And if Albert up here always chooses to add a new trick, right here, so that means I don't have to pay attention to anything up here. I'm just going to look here. So if I'm Horatio, I know Albert's always going to choose to add a new trick. My Nash equilibrium becomes this box right here. So if I write it down here, Al equals add, Horatio equals no new trick. And that will be their Nash equilibrium. Because Albert always chooses to add new trick regardless of what Horatio does. And if Horatio knows that Albert's going to go there, he's going to choose between 450 and 400. So he will go here. So this will be the natural equilibrium, so to speak, for Albert and Horatio. Now, sometimes it's worth noting, sometimes like in the golden ball scenario, both players had a dominant strategy. Sometimes neither participant has a dominant strategy. Sometimes one does and one doesn't. Now, the Nash equilibrium can actually be two boxes, as some scenarios have indicated. Now, again, if you have any questions, let me know. Go see if you can figure out the Nash equilibrium on the front of page 4.